Hello everyone, this is my video for pointers and references. Okay, just like before, we're going to create an int variable called p, except for now we're going to have an asterisk in front of it representing that it is a pointer. Pointer is a variable that points to a memory address. In other words, we use it to point to another variable's memory address of type int. So in other words, we can use p to find other variable addresses, such as, like, say if I had an int number variable that had the value of 9 in it, I could use p to get that memory address and have it point to that memory address and then alter it or change it around. Okay, in order to do that, we need to know the address of the operator. Okay. In order to use the address of operator, first we have to have a variable that we're going to point to. It's like I was just talking about. So we're just going to create a variable x, and then we're going to create a pointer p, and then we're going to have p equal the reference to x. So you see, you put the and symbol in front of it, and that will create a reference of x and pass it to the pointer p. Okay, so now p will hold the address of x. Okay, now we're going to go into dereferencing. Okay, so we're creating another variable x and putting the value 25 in it. We're creating the pointer p, and then we're putting the referenced value of x or the referenced address of x into p, so that p could then hold the value of x and be printed out here using the cout statement. We use the asterisk, unlike the way we did it before when we were actually just assigning the address of the operator. So we're we're just putting the address in it. Here we're actually using the value inside of the address. Okay. And then the same here when we try to actually assign a value to p, or the p pointer, we actually have to use that asterisk in order to store 55 inside of p. Stores 55 in that memory location. Okay. Pointers must always be initialized. So whenever you create a pointer, you always want to either make it 0 or null. Null meaning there's no value. Okay, so that always has to be done. And then the next thing I wanted to talk about was dynamic variables. Dynamic variables are created at runtime, which means that they're not hogging up all your memory when your program first starts. Like instead of, like, say you needed an array of people, but you didn't need that array of people until you got to the end of the program. Well, it wouldn't make sense to create that array of people right away if you don't need to. Okay, so you create it when it's needed. So this is what dynamic variables do. Okay, so you use the keyword new and then the name of the variable that you dynamically want to create. This lets you create a single dynamic variable. Okay, and then the main usage is actually for arrays. Just from as far as what I've seen, you want to do this a lot when you have an array. So that way, like say your program in the beginning, like I said, you're creating that list of people at the end. Of course, you're going to have more than one person usually for whatever you're going to do. So you could have it tally up the amount of people that would log into the program, and then use that number or that counted number to decide how large the index of the array is going to be. Okay, so this could be created dynamically and only create the necessary slots for the array. So in other words, we wouldn't create a max size, like like we normally would for arrays, we would have to create um, a constant size. You would have to put like 50 or something like that in there to tell it how big the array is supposed to be. In this case, we don't really have to do that. We can use a variable of information that we already retrieved, which would be the counter for the amount of people. Put that counter in there, and then it would only create the necessary size of the array that it needed. That's the whole point of creating things dynamically. Okay, one things to look out for is dangling pointers and memory leaks. All dynamic variables must be deleted after use. Okay, so whenever you get done creating a variable or an array of dynamic variables, you want to make sure that you use the keyword delete and then the variable name in order to remove it from memory. Now, there's other things that you want to look out for too. The difference between dangling pointer and a memory leak is that when a pointer contains an address that no longer exists, it becomes dangling. In other words, if you have two pointers pointing to the same memory address and you delete it with one pointer, the other pointer is still going to be pointing at it. So you got to make sure that you change the view of that pointer to another address before you delete it. That way you don't have dangling pointers. Okay, another problem could be memory leak. When an address in memory is lost from pointer view, you can't retrieve it any longer, then you have an area in memory that can no longer be unloaded. In other words, it's going to be stuck there until you reboot your computer. It's going to eat up your memory. It can cause a lot of problems for computers and can actually can affect things in other programs and stuff like that, which could be really bad. Usually it'll crash. That's what you could hope for more than anything. But you always got to try to be thorough and delete your dynamic variables and arrays. Okay, that's pretty much it for this video.